Hello fellow astronomers, I'm Patric McCready.
I'm Cridge.
And today we'll be explaining the phenomenon known as black holes. For this video we will be discussing how black holes affect life in the universe. We will begin with what a star is and proceed to how its cycle can create a black hole. And then after describing the characteristics of a black hole, we will discuss how a black hole can affect life in the universe. A star is a luminous ball of gas held together by its own gravity. It does this by fusing hydrogen into helium throughout the course of its life. Only massive stars of at least 9 solar masses or more can become black holes, so we will only be going over stars of more than 9 solar masses throughout the course of this presentation. A star's main goal in life is to get to an equilibrium state, which is when the gravity pushing towards the core equals the fusion pressure pushing outward. When it reaches this point, it will make a transition into becoming a main sequence star. A star will spend the majority of its life as a main sequence star fusing hydrogen into helium. It will continue to do this until all the hydrogen is gone. When this happens, the core must stay hot enough for hydrogen to continue to form helium. Maintaining this will force the outer layers of the star to cool down and expand, becoming a red supergiant. This core will continue to fuse from one element to a denser element until it reaches an iron core. This is as far as the fusion will go, and therefore the equilibrium will end. At this point, gravity will finally take its toll on the star and collapse, causing a supernova. There are 2 types of supernova, labeled Type 1 and Type 2. Type 1 supernova originate from white dwarf stars with a similar mass to our Sun. A supernova is not guaranteed from these stars, but is possible. However, they cannot form black holes. Type 2 supernova come from massive stars, such as the ones that we discussed while going through a star's life. It is possible in a Type 2 supernova that the remnants left behind after the explosion could equal about 3 solar masses, which would form a black hole if the star was massive enough during the main sequence. For this to happen, the star would have to be at least 25 times the mass of our Sun. Otherwise, the remnants would be less than 3 solar masses and would likely not form a black hole and instead form a neutron star. Black holes can only form from Type 2 supernovas from very massive stars. In a way, it's formed when a very massive star caves in on itself. Its gravity is so intense that not even light can escape its pull. Its gravity is like this because the black hole is so dense and compacted into such a small space. Since no light can escape from it, a black hole cannot physically be seen. So instead, we look for its effects around our surrounding universe. As you can see here, we cannot see inside the black hole, but instead we look for evidence in the matter around each black hole. The matter orbits the black hole just like planets orbit a star, but instead we cannot see the black hole itself. In reality, a black hole is tiny compared to a star or even a planet. When looking at depictions of it, it seems larger due to all the surrounding light being sucked in. Seen here in red is the accretion disk, where light is engulfed by the black hole and no light can escape it. This accretion disk gives off X-ray light, and astronomers have found ways of looking at black holes using that X-ray light that is given off. The event horizon, seen here, is the extent the gravity of the black hole has on the universe surrounding it and determines the boundaries of the black hole's gravity. Outside the event horizon, nothing can be affected by the black hole. Black holes' effects on the universe are largely theoretical as of right now in many ways, as astronomers look to learn more of what happens to matter taken in by the phenomenon. Some believe that other universes could be located inside the black hole if stars, planets, and light that are taken in by the black hole are still intact. This also means it is possible that our universe is located inside a black hole that takes place somewhere else in the universe. Either way, this would have a large impact on life in the universe and an even larger impact on how we discover other life. However, if these planets and stars were destroyed in the process of the black holes pulling them in, it would also hinder the possibility of life in the universe, as the black hole would destroy the things needed to yield it. Anything located inside the event horizon would then be destroyed, and in some cases this could be about as large as our solar system, or if not larger. As you can see here, a solar system is being sucked inside the event horizon and destroyed in the process. On a less dramatic note, black holes can hinder our ability to discover more exoplanets, since the event horizon seen here can be so massive and also is completely empty apart from the black hole in the very center. It can take up a good amount of space where we look behind it to discover more exoplanets capable of supporting life. As you can see here, our telescope here on Earth is trying to view these planets and stars in the distance, but the black hole is taking up all the light in the surrounding area, and so we are not able to see these planets behind it. As you can see, these planets are not visible as the black hole is blocking them, while this space here at the bottom is visible. Black holes are either very destructive or just a passage to another place that may hold life in the universe. Either way, black holes are a very big factor to life besides ourselves existing in the universe. Thank you for watching. I hope you enjoyed our quick presentation of the properties and effects of black holes.